Okay. Hello, my dear students. This is your online English medium combined mathematics class. I'm Rajika Wimalarathne. So today is the 8th day of your combined mathematics English medium class. So today is the last day of your foundation course. So last 7 days we have done about algebraic fractions, binomial expansions, factorizations and equations. So today also I'm further discuss the things about equations. Then thereafter the full foundation course will be completed. Thereafter we can start your syllabus. Okay, let's start from the beginning. Okay, let's start. Today I'm gonna do special quadratic equation type that comes with irrational relations, and also I'm gonna do simultaneous equations. Then we can full stop foundation part. Okay. Now check this one first. You consider here x root x minus 1 equals 0 equation. I'm going to solve this one. Root x minus 1 equals 0. Very simple equation. Very simple equation. So here root x equal 1, you square both sides. Here x equal 1 square, then we get x equals 1. X equals 1. That's how we solve this one. Here especially we call this one irrational equation. Irrational. Equations. Irrational equation. So that contain square root values. That contains square root value. That's the specialty. That's the specialty. So when you are doing this type of irrational equations, you have to remember here within square root negative values we say imaginary, or otherwise not real. Within square root negative value not real. There we call imaginary. Okay. Then if you have denominator zeros, here special thing. Here not real. Here second one, if you consider denominator here, then you say denominator not equal to 0. Denominator not equal to 0. Denominator zeros are undefined. Then when you are doing fractions, you have to remember no denominator zeros are possible. When you are doing fractions, you have to remember all irrational expressions, here square root relations, within root value must be positive to get real solutions. Okay. Now here two special things. Now you consider here, when you see 3 to the power x equal minus 1, then 3 to the power x equal minus 4, then minus values are impossible, no? Then here power, by changing this power we can't take this negative value. Here we say it is contradiction, that means cannot happen. Then if you have fourth relation, 3 to the power x, a to the power x equal a to the power b, then you can equate these indices. Bases are same, no? Then you can say x equal b. That is possible. Then fifth one, a to the power x equal b, here exponential type. So when you need to subject this x, you write this say x equal log a base b. Then here write x equal log a base b. Here a to the power x equal a to the power b, you say x equal b. 3 to the power x equal minus 4, here you say it is contradiction. We cannot get negative value. And here these are specialty of some special equations. So today, last day, we did this one and we did this one, and still we haven't this one. Under logarithms we do that. Okay, under logarithms we do this type of relations. So anyway, here you have to remember this one. If we have denominators, we have to forget denominator zeros. Then if you have irrational relations, here negative values are imaginary. We forget that negative values within square root. Then we're going to specially consider about this type of relations. That is called irrational equations. Irrational equations. Very important thing. It is somewhat little harder than previous equations. Okay, then write down topic. Write down topic. Irrational equations. Irrational equations which can be reducible. Irrational equations which can be reducible. Irrational equations which can be reducible to a quadratic equation. Which can be reducible to a quadratic equation. Okay. Now first you write this one, try this example. Write this example only, don't write the other part. Only example. Already this part. So here you got x equals 1. When you are evaluating irrational equation, you have to check these solutions whether it satisfies original equation. So x equals 1, you put original equation. Here 1 root, no? 1 root, it is possible because within square root we get positive value. Therefore it is possible, it satisfies the equation. Then 1 root minus 1 we get 0. 1 root minus 1 we get 0. Likewise we have to check it. Okay, with star mark write down. When evaluating irrational equation, when evaluating irrational equation, when evaluating irrational equation, when evaluating irrational equation, the solutions must be verified. The solutions must be verified. The solutions must be verified with the original equation. The original equation. The solutions must be verified with the original equation. Within bracket write down. Within bracket write down. The solutions must be substituted. The solutions must be substituted. The solutions must be substituted to the original equation. To the original equation. Then it doesn't contain within square root negative values, within square root negative values, within square root negative values, and also both left hand and right hand side of the equation both left hand side and right hand side of the equation, signs must be same. Signs must be same. Signs must be same. Okay. Now you put this note. Put this note. Then here you have to remember, within square root negative values are impossible. Within square root negative values are impossible, and no denominator zeros possible, no denominator zeros. So if you have exponential type, negative values are impossible. Here negative, no, that cannot happen. That can't happen. Then a to the power x, a to the power b are same, then bases are same, then indices must be same. Indices must be same. For here different bases, you can subject exponent by taking logarithm. X equal log a base b, x equal log a base b, likewise. Okay, write them. Those are not only for irrational equations, but that is possible with any other type also. Now let's do another example. Check this one all. Usually irrational equation contain square root relations. So from the beginning you have to remove that square root by squaring both sides. Okay? Not each term. You have to square both sides. Then expand and remove square root and subject x. That's the procedure. Okay? If we have only one square root, we have to square only one times. But if we have more than two square root, or we have especially say two square roots, then definitely we have to square two times. Okay? Let's see that. You consider here x squared minus 1 root equal 4. Here irrational relation. Now x square minus 1 equal 4 squared. Then x square equals 16 here, with this one 17. Then x value plus or minus root 17. We get plus or minus root 17. Here this is original equation. Here we have reduced to this. By squaring, equation will be changed, okay? But that contain original equation solution. That's why we have to check here whether solutions are true. Now let x equal root 17. Here verification step, okay? Verification step. Take left hand side. Here x square minus 1, no? X square minus 1 root. Then substitute root 17 for x. Then square means 17 minus 1. Here positive, no? Positive, no issue. Then right hand side 4. That also positive. You have to check only signs. Then that is possible. Therefore, signs are same. Therefore, you say x equal root 17 is a solution. X equal root 17 is a solution. You have to check only signs. Then let x equal minus root 17. X equal minus root 17. You take both. Then first check root 17, then check minus root 17. Then left hand side, take this one, x square minus 1, no? That is original equation, you put minus root 17 here. Minus root 17 square mean, again that will be 17, no? No issue, that is 17. Then that also 16 root, it is positive. Positive, right hand side, 4, it is positive. Then no issue, they are same. You have to say x equal minus root 17 also for solution. There can be some solutions which are not satisfied the original equation. Later we will see how it is happen. Okay, do this example again. Okay, now see this one, see this one. For x minus 3 square root plus 2x plus 3 root equals 6. Here your tutorial page number 8. Page number 8. Here this is irrational equation again. Irrational equation. Tutorial page number 8. Okay, see this one now. This is very special type equation, irrational. As first step, you have to remove square root. You have to remove square root. Okay. Then you can't square each term one by one. You can't square that way. But you can square both sides. You can square both sides. Then initially I told you if we have one irrational term, if we have one square root, then we have to subject that one and then we can square. Subject that and then square. Then we can remove that square root. But if we have two square roots, we have to square twice. We have to square twice. Okay. Then remember this one. 1 plus 2 equal 3, no? 1 plus 2 equal 3. Then 1 squared plus 2 squared equal 3 squared. It is impossible. Here 1, 4, 9, 5 equal 9. Then this procedure wrong. This procedure wrong. Okay. But if you square both sides, 1 plus 2 square, 3 square, then 9, here 9, 3 square 9. Then that is possible. This is completely wrong. Then term by term you can't square. Okay. Both sides you can square. Then here you have irrational equations. I'll take this one root a and I'll take here root b equal 6 now, or otherwise you take ab. Here take ab. Then here a, here b. A plus b equals 6. Then square both sides. A plus b square equals 6 squared. Then expand a squared plus 2ab plus b squared equal 36. Here this is binomial power 2, we have 3 terms. Binomial power 2, we have 3 terms. then a square plus 2ab plus b square. Then a equal 4x minus 3 root, then a square mean you have to square this. 4x minus 3, 2. A mean with square root 4x minus 3 root. B mean 2x plus 3. B square mean you have to remove square root here, 2x plus 3. And right side 36. 36. Okay. Now here you see this one. Previously we have square root in two different places. Plus sign separated, no? Plus sign separated. Two different places with plus sign separated. Now after squaring that turn into single square root term. Here you can put here single square root, no? Now here my product, no? We have product here. Then we can put common square root. Then we have only one place square root. Then you subject this one and square it. Then before that simplify 4x, 2x, 6x, 3 cancel equal 36. Here 6x, 2 times 4x minus 3, 2x plus 3, all in root equal 36. Now to remove this square root, you subject this one, that means put the other one, the other side, square both side, then you can remove square root, no? That's the procedure. Okay, let's start it. Let's start this example. You by the side, you better note this, huh? මම මේ ටික කියන්නේ මේ ඔයාලා අතින් මේවා මිස්ටේක් වෙනවා. මොකද ඔය පාර්ට් එක අපි කරන්නේත් ඒකින්ද තමයි ඇල්ජිබ්‍රා පාර්ට් එක. Okay. Better note this and continue. Do up to this one. Do alone. Now let's move further. Subject this one and before that cancel by 2. Here 18, here 3. Put this on the other side. Here 4x, better to expand root items. Here 8x squared, do with me. 8x squared, 12, 6, 6x minus 9 root. Here 18 minus 3x. 18 minus 3x. Do with me. Then you can take 3 outside, 6 minus 6. Now we can square both sides, no? Square both sides. Then here, again square. 8x squared plus 6x minus 9 equal, here 3 square 9, 6 minus x squared. You have to square both sides. Then 9, 36, 12x, x squared. Then you put all terms the other side. Then 8x, 9x squared, then put all terms other side, then 8x squared, 9x squared, x squared, 108, 6, here 114, no? 114x, and here 243, 9, 3, sorry, 2, 43. This is 9, 36. Continue. Current method value check කරන්න. 243, no issue, ne? Okay, continue. Three, ne? From value, here x square minus 114x, 333. Okay, continue. Okay, now then factorize x, 111, 3 minus 0, then we have solution x equal 3 or x equal 111, x equals 3 or x equals 111. Now you have to check this solution. You have to check with original equation. Okay, now see that take left hand side, x equal, let x equal 3 first. Let x equal 3, left hand side, 4 into 3 minus 3 root, 2 into 3 plus 3 root. Here 9 square root, here 9 root, we get 6. Now that equal right hand side, no? Therefore, x equal 3 is a solution. X equals 3 is a solution. So when you are doing always, you haven't get this type of verification step, okay? You get only solutions. Then now we have to go further. We have to substitute with the original equation. then you have to verify the solution. Now similarly, let x equal 111. Let x equals 111. Take left hand side. Here original equation you substitute. Here this is original equation. Original one 4x minus 3 root plus 2x plus 3 6 plus 3 root. Okay. So this is not original one. Okay. We have changed that. We have changed. Okay. Continue. X equals 111. Here when you substitute, that get greater than 6 value. 2 times 111 plus 3, that's surely greater than 6 now. Then not compatible with right hand side. Therefore say x equals 111 is not a solution. Is not a solution. X equals 111 is not a solution. Okay, then when you are doing irrational equations, you have to remember that. So by squaring, you remove square root relation. So if you have two square roots, definitely you have to square twice. Thereafter, get solution for that equation. Okay, get solution for that equation. Then finally, verify the result with original one. That is very important step. Okay, now take your tutorial. Page number 11, page number 12. We have 3 questions. Page number 12, we have 3 questions. In that exercise 25, 26, 27. 25, 26, 27. 25, 26, 27. Okay, you start it. do alone. X plus 2 root x plus 7 root x plus 9 root equals 7. Okay, square both sides. X plus 2 root x plus 9 root equals 7, whole thing square equals 7 squared. Here binomial, then x plus 2, 2 times product of these two, x plus 2 root x plus 9 root, here x plus 9 equal 49. Simplify x 2x 2 9 11 2, here within square root x squared plus 11x plus 18 equal 49. Then put these two the other side, x squared plus 11x plus 18 root 49 minus 11, 38 minus 2x. Now it is divisible by 2 now. X squared plus 11x plus 18, 19 minus x whole thing square, again square both sides. Okay, then here x squared plus 11x plus 18 equal 19 squared. 2 into 19 into x, this is binomial, plus x squared. Now simplify. Here 38, 11, 38, 48, 49. 19 square minus 18. 49 is equal 19 square minus 18. Then get the value 19 squared. $361 minus 18. $343 divided by 49. Then 49 into 7, no? Then x equals 7. We get x equals 7. X equals 7. Then now we have to check this solution. Let x equals 7 with original equation. Here this is original equation. Here this one given one original equation. Substitute 7 here. Here 7 plus 2 plus 7 plus 9. Then here 9 root 3, 16 root 4, 7. We get right hand side. Therefore, x equals 7 is a solution. X equals 7 is a solution. Do alone, na? Question number 26. 26, 2 into x plus 1 root minus 3 into 2x minus 5 root equal x minus 2 root. Here we have three irrational relations. So definitely we have to square both sides, no? First you square it. So here 2 into x plus 1 root 3 into 2x minus 5 root square equal x minus 2 root squared. Then here perfect square, here expand, here square of this 4 into x plus 1 plus square of this 9 into 2x minus 5 minus product of these two and times 2. Then 2 times 2 into x plus 1 root 3 into 2x minus 5 root. In that expansion, okay, right side x minus 2 only. Remember a plus b whole thing square, a square plus b squared plus 2ab, no? A minus b whole thing square, a square plus b square minus 2ab relation. It's binomial. Simplify now. 4x, 18, 22x. Here 18, 4, 22. 40 minus 4, 36. Minus 36. Here 12, x plus 1 into 2x minus 5 root. Right side x minus 2. Further simplify. Then here take x minus 2 this side. Then 21x 36 34 minus. Put this on the other side. 12. Here expansion x squared 2x squared. Here 2x squared minus 5x minus plus 2x minus 3x minus 5. Now check this one. Here 45. 45 plus 4, 41. 41 minus 2, 39. 39. Now it is divisible by 3. Here 4, 13, here 7. Then 7x minus 13 equal 4 times 2x square minus 3x minus 5 root. Now again you have to square both sides. No? 7x minus 13 squared. Here 16. Here remove square root. 2x square minus 3x minus 5. Continue now. Continue. 49 x square 169 minus 2 into 13 into 7x equal 32x squared 48x 80. Then 49x squared 32x squared 17 169 80 249 and here 26 into 7 182 minus 182 minus 48 134x 0. You can simplify it now again. කේස් එකක් තියෙනවා වගේ ෆැක්ටර් හොඳ ෆැක්ටර් නැහැ නේ. ඊළඟට එන්න කමන්නේ. ඔතනින් තියලා ඊළඟට යන්න. මේකේ හොඳ ෆැක්ට් එකක් තියෙනවා වගේ x equal minus b plus or minus b square minus 4ac 2a 134 plus or minus yeah 134 square 4 into 7 into 249 32 2 over 17 මෙතන මේ කැල්ලකින් මම ගත්තේ හොඳ ෆැක්ට් එකක් තියෙනවා. ඔච්චර ඔයගේ ලොකු ඒවා නම් හම්බෙන්නේ නැහැ අපිට සිම්පල් ඒවා හම්බෙන්නේ quadratic එකේ. Okay. Then we have two solutions. 16 yes 67 67 plus or minus 16 divided by 17. Then two possible answers. Complete that one. (83 over 17) x equals 3. Now check with original equation x equal 3. X equal 3, substitute here. 3 minus 2, 1. Substitute x equal 3 here. 3 plus 1, 4. Root 2. 2 times 2, 8. Here 8. So when you put 3 here, 6 minus 5, 1. Then 8 minus, here 3, no? 6 minus 5, 1. Minus 3. Minus 3. Here substitute 3, 4, 2, 4. Here 4, no? 4 minus 3, 1. Then this is possible answer. X equals 3, possible answer. Then x equals 83 over 17. Here 83 over 17. 83 over 17. And put 83 over 17 minus 5. Here within root we get negative value, no? Then this is impossible answer. This is wrong. Okay, then last one. 3x minus 5 root. 3x minus 5 root minus 2x minus 5 root equal 1. Now इसका both side Here 3x minus 5 plus square of this and square of this, 2x minus 5 minus 2 times product of these two, 3x minus 5, 2x minus 5, 1. Here 3, 2, 5, 5, 5, 10, 2 root, here 6x squared, 15, 25 plus 25, 1. Put this on the other side and take 1 here. 5x minus 11, 2 into 6x square minus 25x plus 25 root. Is that okay? Here 5x, 10, 1, 11, 2, okay now. Then square both sides, 5x minus 11 squared, 4, 6x square, 25x, 25. Now here 25x square, expand 110 minus 110x plus 1 to 1, 24x squared minus 100x plus 100. Okay, then 25x squared, 24x squared, x squared, get all term other side, 110, 100 minus 10x, 121, 121. Now we have factor here, x, 7, 3, minus, 0, x equals 3 or x equals 7. We have two possible solutions. Then check solutions. When x equals 3, left hand side, substitute 3 with original equation, here original 1, 3 into 3, minus 5 root, minus 2 into 3, minus 5 root. Here 9 minus 5, 4 root. 6 minus 5, 1 root. Then 2 minus 1, 1. Equal right hand side. Therefore, x equal 3 solution. X equal 3 is a solution. Then x equal 3 solution. Similarly, you check x equals 7. Similarly, you check x equals 7. Okay, then again substitute x equals 7. When x equals 7, left hand side, 3 into 7 minus 5 root, minus 2 into 7 minus 5 root, 21 minus 5, 16 root, 9 root. Then 4 minus 3, we get again 1, that equal right hand side. Therefore, x equals 7 is another solution. X equals 7, another solution. Two possible solutions, both are possible. Okay, now take your tutorial and let's move further. Now that's all about quadratic type relations and reductible quadratic type. That's very important relation, okay? Now last section, simultaneous equation part, equation of two variables. Go to page number 12. Go to page number 12 and we have few examples. So you start analyzing that. Do one by one. Then thereafter we can move to the last exercise, solving simultaneous equation part, exercise 4. Exercise 4 and exercise 5. Okay, first do alone. Page number 12, analyze examples. Do alone. Okay, let's start. Now see simultaneous equation shortcut method. Check this on all. So especially two variable simultaneous equations. Now you consider here this pattern ax plus by plus c equals 0. Here we call two variable equation. Get this on 1. Then the other equation a2x plus b2y plus c2 equals 0. Now we have first equation, second equation. Format xy constant pattern. Both are given in same format. Now see shortcut method. So here first unknown x, second unknown y, here constant term. So when you find in x, you write as division. When you find in y, again write as division. So numerator will be, you're going to find x, no? You're going to find x. Cross this one and cross multiply only coefficients. Here b1, c2. And cross multiply here b2, c1. And subtract. That is numerator. Then denominator, cross constant. Then do same thing. a1, b2. a2, b1. Subtract. That will be x. Directly x. This is shortcut method. Okay. When you find in x, cross this x, cross multiply coefficients only b1, c2, b2, c1, subtract. Cross constant, do same a1, b2 minus a2, b1. Subtract. That is x. When find in y, you follow same technique. Cross this y, a1, c2, remaining a1, c2, c2 minus a2, c1. Denominator, cross constant a1, b2 minus a2, b1. It is very important to remember when you are finding second unknown. Here first unknown, second unknown, you have to put minus sign here. This is direct technique. Okay. You can apply that one. You have matrices and determinant lesson. Then this comes with matrices and determinant lesson. This is final results. That's how we get. Okay. Now see this example. Example see 2x plus 3y plus 1 equals 0. X plus 4y minus plus 2 equals 0. Let's take this. When you find in x, you do this cross this one, 3 into 2, 6. 4 into 1, 4. Subtract. Then cross constant, 4 into 2, 8. 1 into 3, 1. 1 into 3, 3. Subtract. Then here 2 divide by 5. That is x. When find in y, here cross this y, 2 into 2, 4. 1 into 1, 1. Subtract. Denominator cross constant, 2 into 4, 8. 1 into 3, 3, and you have to put minus sign here when you find the second unknown. Here 4, 1, 3 or 5 minus. That's how you get variable x and y. Solutions for that simultaneous equation. Simple technique, okay? Okay, write this direct technique, shortcut method. Examples as well. Identify the pattern when you find, first write x, y constant order, x, y constant order. When finding x, first unknown, x first unknown, cross this one, multiply coefficient, cross multiply, 3 into 2, 6, 4 into 1, 4, subtract. Then cross constant, 2 into 4, 8, 1 into 3, 3, subtract. Then here x. When finding y, cross this y, do same, 2 into 2, 4, 1 into 1, 1, subtract, then cross constant, 2 into 2, 4, 8, 1 into 3, 3. And definitely when you find it second unknown, you have to put minus sign outside. That is direct technique. Huh? Okay. I'll do another one. Do with me. Another example. 2x minus y plus 5 equals 0. Minus x minus 2y plus 1 equals 0. Here x. When finding x, close x, multiply minus 1 into 1, minus 1, minus 2 into minus 5, minus 10. Subtract, close constant, 2 into 2, minus 4, 1 into 1, 1. Minus 1 into minus 1, 1. And subtract. Then 10, 9 or 5. 9 or 5. Get y. Put minus sign outside, otherwise you will miss that. Then cross y, 2, minus 5, minus 5, denominator minus 4, minus 1. Here same denominator. Then here 7, divide by 5. Here 5, 2, 7, minus 4, 1, 5. That's how we get. Okay? Very simple technique. Okay. Then you try these questions. Do them soon. Use same technique. If you have doubt, do with me. Here this is specific technique, okay? Specific technique, finding unknowns. Here at first step, that must be given in the order x, y constant. X, y constant order. All are there. X, y constant, both are in same order. Then here this is we call first unknown. Here second unknown. And here constant, no? Constant. So when finding first unknown, anyway, both here it's like division, right? Like division. When you find in first unknown, cross this one, cross first unknown, and multiply coefficients. -1 into -1, it is +1. Right here. Then do same thing. -3 into 5, -15. -15, and you subtract. Then denominator, you cross constant, do same thing. 4 into -3, -12. -2 into -1, -2. Now simplify. Here 16 divide by 10, -10. Then 8 divide by 5. That's how we take coefficient x unknown x. When finding y, again write like division, you cross this variable y, then 4 into -1, multiply here 4 into -1, -1, -4, 2 into 5, 10. Subtract, and you have to put minus sign outside. I told you when finding second unknown, you have to put minus sign outside. And here denominator, cross constant, follow same technique. 4 into 3, -12. 2 into 2, -2. -2. Here you have to subtract here. Then -14 plus 14. Here 10. -10. 7 over 5. -7 divided by 5. Here -8 divided by 5. -8 divided by 5. -7 divided by 5. Nah? Continue. Here there's a pattern. You have to remember that pattern. Then only you can do that one at once. Okay. Otherwise you can do usual technique. You eliminate one term, remove one term, then find the other. Okay. That's also general thing. Question number 4. First unknown x. Cross this one. 5 into -2, -10. -4 into -1, 4. Subtract. Then cross constant. 1 into -4, -4. 2 into 5, 10. Subtract. Then -14. Divide by -14. Here -14, -14, 1. When finding second unknown, you follow same technique. Here denominator will be same, -4, -10. Numerator, cross y. Then here -2. And here -2. -2. Then y value 0. X value 1. මිස් එකක් තියෙනවා. -10, -4, minus, here minus 10, minus 4, cross constant, minus 4, minus 10, minus 14, okay. Then y, cross this one, minus 2, minus 2, 4 minus 10. Okay, no issue, no issue. Identify the pattern, na? Here minus, na? So here next one, first variable x, write like division, then class x, 20 minus 2, class constant, here 3 minus 8, 18 divided by 5 minus, 18 divided by minus 5. When find in y, write like division, then denominator same, no? We have to cross constant, 3 minus 8, then numerator class y, sorry, numerator term here class y, here minus 15 and minus 4, minus 4. Here minus 15, 4, 11 over 5, minus 11 over 5. Eleven over 5. Okay. Now see this example. See this one. Here 1 over x plus 2 over y minus 4 0, 2 over x minus 3 over y plus 1 equals 0. Okay. Now previously x in numerator, now x in denominator, y in denominator. Na? Now see, let 1 over x equal a, 1 over y equal b. I'm going to use substitution. Without substitution we can proceed, okay, but anyway I'm going to use substitution. Here this one you can write 1 over x mean a, 1 over y mean b. Then by this 1 over x a, then here 2a, 1 over y mean b, 3b plus 1 equals 0. Now we know how to get directly a, b value here, two simultaneous equation. Then find them. A, cross this one, 2 into 1 2, minus 3 into 4, minus 3 into 4 12. Subtract, cross constant, here minus 3, minus 4. Then 10 over 7. Here minus 10 over minus 7, 10 divided by 7. That is a value. Similarly, you find b value. B value, cross this one, do same. Here 1, minus 8, put bracket minus outside. Here cross this one, 1 minus 8. Denominator, cross constant, minus 3, minus 4. Here 8, 9 divided by 7. here plus 8, 8 plus 1 9, minus cancel, 9 divided by 7. Then a equal 10 over 7, b equal 9 over 7. Then you can obtain xy. No? Then we got a equal 10 over 7. Then you better write 1 over x 10 over 7. Then x value take reciprocal 7 over 10. Then here y equal 9 over 7 equal 1 over y. Then y value equal take reciprocal 7 divided by 9. 7 divided by 9. Okay. Then do this example. Here I used substitution, but that is not compulsory. Yeah? If you can do at once, you do. If you have vision to do this one, then do that one. Huh? Anyway, first identify simultaneous equation. Okay, you try this. Okay, try this one. First you identify simultaneous pattern. No need to do substitution, but if you can write, just write that one. Huh? Take time. First unknown 1 over x, second unknown y. Then when finding first unknown, cross this one, then minus 1 into minus 1, minus 1, minus 2 into minus 5, minus 10. Cross constant, 2 into 2, 4, 3 into minus 1, minus 3, subtract. Then 1 over x equal Here 10 minus 9 over 7. Then x equals 7 divided by 9 minus. When finding second unknown, you follow same technique, close this one, but here you have to put minus outside, close y, 2 into minus 1 minus 2, 3 into minus 5 minus 15, subtract. Then close constant, 2 into 2, 4, 3 into minus 3, minus 3. Then here 13 over 7 minus 13 over 7. No need to put substitution, you can just identify variable 1 over x, first unknown, 1 over x subject, and find it. Here y, find it. Something wrong here, no? Here cross this one, here plus 1, 11, no? 11 over 7, plus 7 over 11, plus 7 over 11. Question number 7, 2 over x minus 3 over y minus plus 5 0, 3 over x plus 3 over y minus 1 0. You do? Here first unknown 1 over x cross x, here minus 3 into minus 1 plus 3, 3 into 5, 15, subtract, close constant, 2 into 3, 6, 3 into 3 minus 9, subtract. Then here minus 12 over 15, then that is divisible by 3, no? Here 4 fifth minus, therefore say x is reciprocal, 5 over 4 minus, no? 5 over 4 minus. Then 1 over y, second unknown 1 over y, cross y, 2 into minus 1 minus 2, 3 into 5, 15, subtract, put minus outside, then denominator cross constant, 2 into 3, 6, 3 into 3, 9, minus 9. Then 12, 15, 17 over 15. Then you find y is reciprocal, 15 over 17. 15 over 17. Okay. Take this question. Here x minus 1 over y minus 2, 3x plus 2 over y minus 1. Then that's all for today. That's all for today. So now up to now we done binomial expansions, factorizations, algebraic fractions and equations. Then foundation level completely done. Then next week onward we can do your syllabus content. Then from the beginning I'm going to start pure mathematics first. Okay, then that's all for today. Have a nice day. Cross this one. Here minus 1 into minus 1 plus 1, 2 into minus 2 minus 4. You have to subtract. Denominator cross constant. Here 1 into 2, 2. 3 into minus 1 minus 3. Subtract. Then here 5 divide by 5, 1. Here 4, 1, 5, 3, 2, 5, 1. Then here second unknown 1 over y. 1 over y. Close this. Here put minus 1, minus 6. Subtract. Denominator cross constant 2 minus 3. Simplify here. Here plus 6 plus 5 minus 5 minus 1. Here plus 5 minus 5 over 5 minus 1. Then y equal minus 1. Y equal minus 1. No? Identify simultaneous pattern first. Huh? So when you are doing all levels, you got simultaneous pattern like ax plus by plus c equals 0 type format. Now here some are different, but same order. It like ax plus by plus c, but not x. It's just like another relation, 1 over x, 2 over y, likewise different relation. But anyway, identify that is like simultaneous pattern. Okay. Now say this one. Say this. 1 over x plus 1, 2 over y minus 1 plus 2, 0, 3 over x plus 1 minus 1 over y minus 1 plus 1, 0. This is also simultaneous pattern. Here one variable 1 over x plus 1. Here 1 over x plus 1. No? Then the other variable, you said 1 over y minus 1. 1 over y minus 1. When you put substitution, then you can identify that. But without substitution, you must have practice to identify that. Then here first variable 1 over x plus 1. Then close this one, 2 into 1, 2, 1 minus 1 into minus 2, subtract, then close constant, 1 into minus 1, minus 3 into 2, 6. Then simplify. 1 over x plus 1, here 4 divide by 7 minus. Here 4 divide by 7 minus. Then cross multiply. 7 equal minus 4x minus 4, then subject x. 11 divided by 4 minus. 11 divided by 4 minus. Okay. Then next unknown, 1 over y minus 1, get previous order, then denominator, same denominator now. No need to think again, you put as it is. Then numerator, you close second unknown, multiply 1 into 1, 1, minus 3 into 2, 6. Now simplify. Here 5 over 7, here minus, 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 minus. Here 5 minus, minus, plus 7. Cross multiply. Here 7 minus 5y plus 5. Then y 2 over 5 minus. 2 over 5 minus. Okay. Do it. Okay, you try this one. X of x plus 1 plus y minus 1, 0. 2x of x plus 1 plus 2y plus 3 equals 0. Try that. X of x plus 1, first variable, here 3 minus 2, cross constant 2 minus 2. Then put case එකක් එනවා. Denominator 0 එකක් තියෙනවා. Denominator 0. Then here 5 divided by 0. Question එක මම නිකන් දුන්නේ ඒකයි අවුල තියෙන්නේ. But anyway, denominator 0, you can take that one, here denominator 0, take this denominator and equate to 0. X plus 1, 0, then x equal minus 1. x equal minus 1. Then here y plus y put minus, here 2 minus 2, 2 minus 2, the numerator 3 minus 2, 5 divided by 0 minus. These are meaningless. Minus 5 over 0. Usually we say that is infinity, but just write this way, then stop there. Stop here. 5 over 0, then you can get x equal minus 1. You can equate denominators to 0. Here x plus 1 equals 0. But here minus 5 over 0, we say that is infinity. Just forget that one. But the pattern is okay. Simplification pattern is okay. Last one. Now let's see 3 variable simultaneous equation. Let's see 3 variable simultaneous equation and its general pattern. Check this. X plus y minus z equal 1. 2x plus y plus z equals 0. 6 minus 3x plus y plus 2z minus y plus 2z equal 1 minus 1. 3 variable simultaneous equation. We have done this. No? Take 2, remove 1. Take these 2, remove 1. We can easily remove z, no? You can easily remove z when adding. Then similarly, by these 2 you take and again you remove z. Then solve simultaneous equation. Continue now. We have shortcut method, later we will discuss that. But for now, you do general way. One, 2, 3. 1 plus 2, 3x, 2y, cancel z, equals 7. 4. Then 2 into 2, minus 3. Here 4x minus 3x, 7x, 2y plus y 3y, 2z, 2z cancel, 12 plus 1, 13. Okay, no? 2 into 2, 4 plus 3, 7, 2 plus 1, 3, z cancel. Then you find x and y. You put this on the other side, 3x plus 2y minus 7, 0, 7x plus 3y minus 13, 0. Then by these two you can easily find x. Okay, find xy, then find z. Substitute and find z. Complete. Okay, here x value minus 26 minus 21 over close constant 9 minus 14 47 sorry 21 4 5 minus 5 over 5 1 no? Minus 5 over minus 5 1 x value 1 y value. So by substituting 1 here you can obtain, okay, x equals 1 here 3 7 4 y equal 2. Likewise you can get substitute 1 3 7 4 take the other side 4 divide by 2 2. Then z xy known, then z equal x plus y, take z here x plus y minus 1, then x equal 1 y equal 2 minus 1 2. Okay, you can use hybrid method. අර කලින් එකත් apply කරගෙන ඔක්කොම mix කරලා ගන්න පුළුවන්. Let's do another one only. 2x minus 3y plus z equals 0. X minus y plus 5z equal 1. Minus 2x plus y minus 3z equal minus 2. Okay, you solve it. Do soon. Okay, now so under this foundation, maths foundation, I did binomial expansions. Factorization, algebraic fractions, and 4 equations. So those all belongs to pure maths. All belongs to pure maths. Okay. So in our mathematics, we have two different mathematics sections. So one is called pure maths, the other one is called applied maths. Pure maths, applied maths. Then applied maths means application of mathematics. Application of mathematics. Then under pure mathematics, we mainly focus on, you read some things about in O levels about pure mathematics. So here we do first one, algebra. and then calculus, and then coordinate geometry, and then trigonometry. So we have 4 sections in pure mathematics: algebra, calculus, coordinate geometry, trigonometry. Then further in applied mathematics, we have again 4 sections. So applied, here first one statics, and the other one dynamic, probability, and for statistic. Again we have 4 different sections. So in your first term mainly focus on pure mathematics, but we have little thing under the statics part, applied mathematics we call vectors. Then we have to discuss something about forces under statics part. So first term here we focus on statics, that is on vectors and about forces. And in pure mathematics we discuss things about trigonometry and some things about coordinate geometry and some things about algebra in our first term, algebra, not about things calculus. But second term we discuss calculus, we start calculus, then all algebra, calculus, coordinate geometry, trigonometry, then combine together and go with those second term, third term, fourth term, so on. Okay, anyway, applied mathematics, application of our pure mathematics, then pure mathematics that we discuss purely mathematics, some are not applicable, some mathematics are not applicable, but in applied mathematics all are applicable in real life applications. Okay, that's the thing. So then we completely done our math foundation part, then we can move to that syllabus part, pure mathematics and applied mathematics next week onwards. Okay, ඒ විදිහට අපිට යන්න පුළුවන්. Okay, එහෙනම් අපි දැන් දවස් 9ක් විතර කරගෙන ආවනේ මේ ෆවුන්ඩේෂන් එක. ඒක අදින් ඔතනින් ඉවරයි. මේක මගහැරන කට්ටිය කීප දෙනෙක් ඉන්නවා. යාලා හිමිහිට ඒක ෂේප් එකේ කරගෙන යන්න පටන් ගන්න. ලබන සතියේ ඉඳලා මම ඔයාලගේ සිලබස් පාර්ට් එක පටන් ගන්නවානේ. විනාඩියක් අහගන්න විනාඩියක්. හරිද? සිලබස් පාර්ට් එක පටන් ගන්නවා. ඒතර ඔයාලට මේ සිලබස් එකේ තියෙන දේවල් මේ එකපාරට සිම්පල් වෙනවා. දැන් අපි ඇඩ්වාන්ස් තැනක හිටියා මේ ඉක්වේෂන්ස් වල. ඒතර දැන් අපිට මේක සිම්පල් වෙලා නෝමල් වෙලා යනවා. හැබැයි අපිට ෆවුන්ඩේෂන් එක දිගට ඔයාලා මේන්ටේන් කරන්න ඕනේ. විනාඩියක් අහගන්න. හරිද? ෆවුන්ඩේෂන් එක දිගට මේන්ටේන් කරන්න ඕනේ. නැත්නම් ඔය සිම්ප්ලිෆිකේෂන් ආයේ අර කලින් තිබුණ මට්ටමට වැටෙනවා ප්‍රැක්ටිස් කරේ නැති වුණා. හරිද? මොකද සමහර සිම්ප්ලිෆිකේෂන්ස් වල එරර්ස් තිබුණා. ඒ එරර්ස් ටික තමයි හදාගෙන ආවේ. ඒතකොට තාමත් ෆ්ලක්චුවේට් වෙවි තමයි යන්නේ. එකපාරට එන්නේ නැහැ. මොකද ඔයාලා ලොන් ටර්ම් ප්‍රැක්ටිස් කරපේවා තියෙනවා. ඒතකොට ඒ වගේ ඉන්හෙරිට් වුණ වැරදි වගේක් තිබුණා. ඒ ටික තමයි ටිකක් ෂේප් කරගෙන ආවේ. එහෙනම් ඔයාලට මේ සිලබස් එකේ කන්ටෙන්ට් එක පටන් ගන්නකොට මුලින්ම මම පියෝ මැත්ස් පාර්ට් එකෙන් යනවා. පියෝ මැත්ස් වලට එන්නේ. ඒතර ඔයාලට ටික දවසක් පියෝ මැත්ස් දිගටම ඉන්නවා. ඇප්ලයිඩ් වලට එන්න පොඩි දවසක් එන්න වෙනවා. මේ ට්‍රිගොනොමෙට්‍රි චුට්ටක් කරාට පස්සේ අතෙන්ට එන්න පුළුවන් ඇප්ලයිඩ් පාර්ට් එකට. කොහොම වුණත් දැන් තාම ඉස්කෝලේ ඔයාලට පටන් ගන්න දවසක් නැහැ නේ. ගිය සැරේ කට්ටියෙන් නම් මේ රිසර්ච් එන්න කලින් ඉස්කෝලේ පටන් ගත්තා. මේ ඔයාලට මම හිතන හැටියට එහෙම එකක් නැහැ. සමහරට ඉන්ටර්නැෂනල් ස්කූල් එක දෙක විතර පටන් ගන්න ඉඩ තියෙනවා. අනිත් ඒවා මම දන්න හැටියට එහෙමකුත් නෑනේ. මොකද ගිය සැරේ ඒක ප්‍රෝග්‍රෑම් එක ටිකක් සක්සස් නෑ. මේ ගිය සැරේ කියන්නේ O levels ඉවරන ගාම අනිත් පැත්තට A level classes පටන් ගත්තා. හරිද? එතකොට මේ ඒක අර කොමන්ලි ගත්තාම හැමෝටම මේ කරන එක සාර්ථක නෑ. හැබැයි ඔයාලා සිලෙක්ට් වෙලා මෙහෙට කියන්නේ ඔයාලාම තීරණය කළා ආවම කරන එකේ ප්‍රශ්නයක් නෑ. හැබැයි සාමාන්‍ය ගත්තාම සමහර ළමයිට ඉස්කෝලේ ප්‍රශ්න දිනවා. ඔක්කොමත් එක්ක බලද්දි ප්‍රැක්ටිකලි එක ඉෂුව එකක් තිබුණා. එහෙනම් මේ සැරේ දන්න හැටියට ඒක කරවෙන්නේ නැහැ. හැබැයි ඔයාලට මම ඉස්කෝලේ පටන් ගන්න කලින් අපි ෆස්ට් ටර්ම් එකේ සෑහෙන කොටසක් ඉවර කරගන්න පුළුවන් වෙයි. එහෙනම් දැන් මෙතනින් එහාට අපිට ගොඩක් දේවල් හොඳට ස්පීඩ් එකේ කරගෙන යන්න පුළුවන්. මේ එකටම තියෙන දේ තමයි හරිද මේ ඔයාලා පුළුවන් තරම් තාම මේ අර O levels ඉවරලා A levels පටන් ගත්තේ නෑ වගේ ඉන්න එපා. එහෙනම් ගෙදරදිත් කරන්න වැඩ සෙට් වෙනවා දැන්. එහෙනම් මේ නිකන් ජස්ට් කරන්න එපා උඩරිම බහැලම කරන්න. ඒ කියන්නේ බහැලම කරන්න හරිද? මොකද නැත්තම් අපි මුලින් ඉඳන්ම කරගෙන ගියේ නැති වුණොත් ඒ කියන්නේ පස්සේ කාලෙකදී අපිට ඔකට එල්ලෙන්න ගියාම ඒක ටිකක් ලේසි නෑ. එහෙනම් ඔයාලගේ පොඩ්ඩක් ඔයාලගේ පොලිසිස් ටිකක් හදාගන්න රූල්ස් ටිකක් ඔයාලටම දාගන්න. ඒ රූල්ස් ටිකත් එක්ක දිගට වැඩ කරන්න. ඒ කියන්නේ එක්සැම්පල් එකක් විදිහට කිව්වොත් සාමාන්‍ය ඔයාලට මේ කරන දේවල් රිපීට් කරන්න ඕනේ කියන පොලිසි එකක් දාගන්න. ඒ කියන්නේ ගෙදර ගිහිල්ලා රිපීට් කරන්න ඕනේ කියලා. ඒක පොලිසියෙන් කියනකන් ඉන්න එපා. ඒ හින්දා අනිවාර්යයෙන්ම ඔයාලගේ පොලිසි එකක් සෙල්ෆ් පොලිසි එකක් දාගන්න ඕනේ. ඒක රිපීට් කරන්න ඕනේ කියන එක. ඒ හින්දා පුළුවන් වුණත් දැන් මේ කරද්දි පුළුවන් වෙනවා කියලා දැනෙනවා. හැබැයි ඔක මේන්ටේන් නැති වුණොත් ආයේ ඔටෝමැටිකලිම බැරි වෙනවා. හරිද? අපේ තියෙන හැටියක් ඒක අපේ ඇඩ්වාන්ස් ලෙවල් සබ්ජෙක්ට්ස් තුනේම තියෙන හැටියක් ඒක. ඔයාලට සෑහෙන ලොකු ප්‍රමාණයක් තියෙන ඇනලිටික්ස් එක යන්න තියෙන්නේ. ඒ හින්දා ඇනලිටික්ස් ටික හරියට ටික කාලයක් මැනේජ් කරගත්තේ නැති වුණොත් ඕක අමතක කරලා ලොස් වෙනවා. ඒ හින්දා අනිවාර්යයෙන්ම මේ එක දිගට කන්ටිනියස්ලි වැඩ කරනවා කියන පොලිසි එක දාගන්න. ඒතර ඒ කරන දේවල් රිපීට් කරනවා කියන එක පොලිසි එකක් දාගන්න. ඒකට ඔයාලා ටයිම් එක එන්ගේජ් කරන්න. හරිද? මොකද නම්බර් 1 ප්‍රයොරිටි එකක් ඒකට දීලා කරගත්තොත් ඔයාලට අවුරුදු 2කින් විතර මේ වැඩේ ඉවර කරගන්න පුළුවන්. දැන් ඔයාලගේ එක්සෑම් එක ඕගස්ට් වලට එනවනේ. ඒතර තව අවුරුද්ද 2ක් වගේ යනකොට මේ වැඩේ ඉවර කරගන්න පුළුවන් අපිට සම්පූර්ණ කරගෙන. ඒ හින්දා එතනින් එහාට ආයේ ෂයි එකක් ගැන හිතන්නේ නැතුව අපි මේ සැරේම ඉවරක් කරගෙන මේ වැඩ ටික ඉවර කරගන්න ප්ලෑන් එකට යන්න. ඒ හින්දා අර ඒ තියෙන ඩිරෙක්ට් ටාගට් එක ආයේ වෙනස් කරන්න මෙපා. හරිද? ඒ හින්දා අනිත් ඒවාට ප්‍රයොරිටි දෙනකොට මේකේ ප්‍රයොරිටි එක අයින් කරලා දෙන්න යන්න එපා. ඉතින් මම අර පහුගිය කාලයක් තිස්සේ දැක්ක පොඩි දේවල් තියෙනද මම මේ කියන්නේ. ඒතර එකක් තමයි මේ අර එක්ස්ට්‍රා වර්ක්ස් තියෙනවා. එක්ස්ට්‍රා වර්ක් කරන්න ඕනේ ගොඩක්. ඒක ප්‍රශ්නයක් නෑ. කිසි අවුලක් නෑ. හැබැයි මේකට හාම් එකක් නැති වෙන්න. හරිද? ඒ හින්දා මේ ඒකට හාම් එකක් වෙන්න දෙන්න එපා. එක්ස්ට්‍රා වර්ක්ස් කරන්න අපේ වෙන මේ ප්‍රෝග්‍රෑම් එකට හානියක් වෙන්න දෙන්න එපා. මොකද ඒක කැඩුනොත් ආයේ ඒක ගොඩ දාගන්න ටිකක් ලේසි නෑ. ඒ හින්දා මේ ඒක එකක්. ඊට පස්සේ අනිත් එක තමයි කන්ටිනියුවස් වෙන එක මාර ඉම්පෝටන්ට්. හරිද? ඒතර කන්ටිනියුවස් වුණොත් එයාලගේ රිසර්ච් එකට සෑහෙන ලොකු බලපෑමක් ඒකේ තියෙනවා. සමහරවිට අතරමැද එකපාරට වහිනකොට කැඩෙනවා. හරිද? අන්න වගේ පොඩි සිද්ධි තියෙනවා ඒක කරගෙන යනකොට. මේ ඒක කන්ටිනියුවස් වුණ නැති වුණොත් එතන රිසර්ච් එකට ලොකු බලපෑමක් වෙනවා. එහෙනම් පුළුවන් තරම් ඒක කන්ටිනියුවස් වෙන්න. ඊට පස්සේ පංචුවල් හරියටම ටයිම් එකට ඇවිල්ලා ඒ වැඩ ටික කරගන්න. මොකද මම කොහොමත් ඔයාලට මම මෙතන කලින් වෙනවා කියලා තියෙනවනේ. මම එහෙම ආපු නැත් දවසක් නැහැ නේ තාම. එහෙනම් මේ ඉස්සරහා දවස් ටිකෙත් එහෙමම තමයි. හරිද? එහෙනම් ඒ ටයිම් පීරියඩ් එකේදී මම ඒක හරියටම ඔයාලට ඒ සපෝට් එක දීගෙන යනවා. ඒක ඊළඟ එක. ඊට පස්සේ අනිත් එක තමයි ඔයාලට එන ප්‍රශ්න ඕන දෙයක් අහන්න. හරිද? චුට්ටක්වත් බය වෙන්න එපා. අහන්න. මොකද මෙතෙන්ට ඔයාලා අනිවාර්යෙන්ම ඉන්නේ රිසර්ච් එකක් දාන්න බලාගෙන ඉන්නේ. ඒතර ඒකට මම ෆුල් බෑකප් එක දෙනවා. මම අනිත් දේවල් වැඩි ලොකුවට කතා කරන්නේ නැතුව කරගෙන යන්නේ ඒ හේතුව හින්දා. ඒ දේවල් කතා කරන්න ගොඩාක් දේවල් තියෙනවා තව. මේ කතා කරන්න කියන්නේ මේ සබ්ජෙක්ට් එකෙන් පිට දේවල් ගොඩක් දේවල් මමත් දන්නවා. හරිද? ඒක මම වැඩි කතා කරන්නේ නැතුව ඉන්නවා. මේ මොකද ඔයාලා මෙතෙන්ට එන්නේ ඒක බලාපොරොත්තු වෙන්න එන්නේ මේ සබ්ජෙක්ට් එක. එන සබ්ජෙක්ට් එකේ ගොඩක් දේවල් මම කතා කරනවා. ඒවල එන ප්‍රශ්න අනිවාර්යයෙන්ම මාත් එක්ක කතා කර ඒවා විසඳ ගන්න try කරන්න. එහෙම ප්‍රශ්න එනවා. හරිද? හදන්න බැරි වෙනවා. එහෙම දේවල් වෙනවා. ඒ කියන්නේ ගණක් හදද්දි තේරෙන්නේ නැති වෙනවා. එහෙම දේවල් වෙනවා. මොකද O levels වල උනාට වඩා වැඩි ප්‍රමාණයක් ඒක වෙනවාමයි අනිවාර්යයෙන්ම. ඒක ඔයාලා අඳුර ගන්න ඕන දෙයක් තමයි බැරි වෙලා හරි ඔක්කොම ටික තේරීගෙන හැමදේම තේරෙනවා වගේ දැනෙනවා නම් එතන මොකක් හරි ලොකු අවුලක් තියෙනවා. හරිද? ඒක ලොකු අවුලක් තියෙනවා. හරිද? ඒකින්ද අර මේ ඒ වගේ එකක් සෙට් වුණොත් එහෙම ඒක එන අවුලක්. ඒ හින්දා මේ ඒක ඔයාලට දෙයක් සිලෙක්ට් කරගන්න තියෙන හොඳ දෙයක් ඒක. ඒ හින්දා මේ වැරදි අපි දේවල් ගොඩක් කරගෙන යන්න ඕනේ. ඒක ජෙනුවින්ලි කරේ නැති වුණොත් එතන ලොකු අවුලක් තියෙනවා. එහෙනම් ජෙනුවින්ලි අපේ ඉම්ප්‍රූව්මන්ට් එක ඇඟට දැනීම කරගෙන යන්න ඕනේ. එහෙනම් ඒ වැඩ ටික අපි ලබන සතියේ පටන් ගමු. හරිද? එහෙනම් ලබන සතියේ මේ ටයිම් එකටම අපි සිලබස් එකේ කන්ටෙන්ට් එක ස්ටාර්ට් කරනවා. ෆවුන්ඩේෂන් කතාව උතනින් ඉවරයි. ඔයාලා ඒ වුණාට මේක මේන්ටේන් කරන වැඩේ කරන්න. අපේ යනවා. හරි. අපි එන අදටතන ඉවර කරමු නේ. Then that's all for today. That's all for today. So now up to now we done binomial expansions, factorizations, algebraic fractions and equations. Then foundation level completely done. Then next week onward we can do your syllabus content. Then from the beginning I'm going to start pure mathematics first. Okay, then that's all for today. Have a nice day.